Okay, let's go to number 5. There are 4 questions here, and from here on, it's pretty much all about integration, right? Let's start with an easy one. What's the integral of, that means an antiderivative of, okay, or the antiderivative of x to the 24th. Remember, you divide this by a number, the number which is one more than that exponent. That's 1 over 25 times x to the 25th plus c. And again, just try to differentiate what you just got, and the 25 on top and 25 will cancel, and that will give you 24. Is plus c important? Well, it is, because we are trying to give all antiderivatives and, I mean, a general solution. So if you don't have plus c, you'll have some points deducted, probably 1 point. Okay, what is 1 more than -6? That's -5. Yeah, so you put that in the denominator, and so this is what you get, right? So that is the correct answer, because -5, if you try to differentiate this, the -5 on the top and the bottom will cancel. The new exponent will be -6, and that's exactly what this is. You could also write this as -1 over 5 times x to the 5th, if you like. Okay, you don't have to, but that's okay too. The next one, what is 1 plus -2/3? That's 1/3, positive 1/3. So it's actually 1 over 1/3. You don't have to write it this way. And then what's next? It's x to the, -2/3 plus 1, which is 1/3. So this is really what the answer is. But what is that? Okay, well, you can simplify this. And I think that's better if you simplify this, because 1 over 1/3 is basically 3, right? So this is what you get. That's okay too. You can also write this as 3 times the cube root of x plus c, and that would do the same. All right, so this one is not 5 times the square root. This is the 5th root of x. So it may be a good idea to write this down as x to the what, -1/5. The x, you use the power rule. Not this one may trigger you to think of some natural log or something, but it's really just the power of x, right? X to the -1/5. Okay, add 1 to -1/5, and you get 4/5, right? So it's 1 over 4/5. You can also write 5/4 if you can do so right away. So this is what you get. All right, so this is 5 over 4, x 4 to the 4 over 5 plus c. Differentiate this, and you can see these numbers will cancel, and the new exponent will be -1/5. So that is the correct answer here. All right, let's go to number 6. So here we have a composition of 2 functions. We have negative cosine, and then you have 4t. And remember, for these, it's good if you, unless you can do this right away in your head, to introduce another variable, u. It's called u substitution, right? Remember, u is so wonderful, just the way u is. And so what is that? It's, let's see, u is 4t. And so that means du is 4 dt. You can write du dt is 4, but this is more of a standard way of writing this. Now, you don't see 4 dt, but you can go ahead and create 1/4 out here. In fact, let's multiply, take the negative sign outside. I'm not changing this to u yet, but see this dt? Because I have 1/4 outside, I can make this into 4 dt. Okay. Now, the negative sign is I just took the negative sign out. And so that shouldn't be too bad, right? That should not be too confusing. Now, I haven't made a transition into the world of t or the u yet, but I am about to. It's -1/4 integral cosine of u, remember, because 4t is u. And now we have 4 dt, which is exactly what du is. Okay, perfect. So this is -1/4 sine of u plus c. Remember, the integral of cosine is simply sine plus t plus the constant. But remember, u is something I just made up. And so I'm going to have to go back to the world of t, and instead of calling this u, I should call this 4t. right? I mean, the question was asked with t, so I don't really have the liberty to leave my u there. -1/4 sine 4t plus c. Okay, so the next one is the integral of secant theta tangent theta. Does it look familiar? I hope it does, because it's precisely a formula you learned. It's secant square plus, well, secant theta plus c. The derivative of secant is secant tangent. That's it, all right? How about cosecant square? Does it look familiar? Yeah, that's cotangent. Or is it? Well, it's almost is, because the derivative of the cotangent function is negative cosecant square. So I would have to put the negative here so that this will be negative times negative, which is positive. Okay, so keep remember your trig functions and their derivatives. Okay, so I have sine cubed and cosine. I can't just simply do this one. I need u substitution. Let u be what? Well, you can let u be cosine, but then sine squared or cube would be hard to describe. So let's just let u be sine of t. And du is going to be cosine of t dt, which is right here. So this one goes right into the world of u. Sine of t, which is u, is cubed, followed by cosine t dt, which we call du. So the answer, 1/4 u to the 4th plus c. But I would still have to go back to the world of t, because u is something I invented for my convenience. So what is that? It's sine t to the 4th, which is sine 4t. You should write it this way. And that is your answer. Okay, let's go to one more. Let's go to number 7, and then we'll take a break at that point. All right, number 7 has 4 integrals, all indefinite integrals. So they will all have plus c, which should be a part of your everyday practice now. All right, so what is that? You could take 4 out if you'd like. You don't have to. The answer is obvious for this one. It's 4 times the natural log of the absolute value of x plus c. I explained carefully in my lecture video why there is an absolute value sign there, but there is, okay? Anytime you have dx over x or 1 over x dx, the same thing, you'll have the natural log of the absolute value of x, okay? All right, so then this next one, all right, well, I can take this, like, let's see, let's just take out 4. You don't have to, but you will see what I'm about to do here. Okay, so I have something that's a little complicated. I can let u be x squared plus 1. Then I have du is 2x dx. I don't have a 2x dx, but no problem. As mathematicians, we can just create what you want right there. I want 2x dx, so I just put that 2 in here. I can do that as long as I divide everything by 2. Now, what you add and what you include inside and outside has to be a constant. Okay, I can't just like put x in here and x out here. But anyway, so this will now give you a new problem. It's 2, and then what's 2x dx? That's du. What's on the bottom here? That's u. Okay, so this is 2 natural log of the absolute value of u plus c. And of course, u is x squared plus 1. So that's your answer here. Now, this is a fine answer. If you want to be elegant, you can change that back to the parentheses. Why is it? I said you have to have the absolute value sign. Yes, that's true. But remember, this thing here is always going to be positive. I don't care what x is, okay? I know this number is at least 1. Could be very large, but it's always positive. So I don't even have to have the absolute value sign there. Okay, tangent. Well, do we have a nice formula for it? Yeah, there is something like that. But if you forget, you can always say tangent is sine over cosine. Okay, always is, always is. And so you can let u be cosine of theta, and then du would be negative sine of theta d theta. And of course, I don't have a negative, but no problem here. As mathematicians, we can create 2 negative signs. like saying, don't say nothing, right? That's that's not true, but I mean, you see what I'm talking about. Double negative will make this positive, okay? So I haven't changed the problem by putting two negative signs. So this is negative, and now negative sine theta d theta is what we call du. Cosine theta is u, so this is negative, the natural log of the absolute value of u plus c. And so this is the negative natural log of the absolute value of cosine theta plus c. And so this is an okay answer. And so that is no problem. Some people may want to, or some people may prefer to write this as the natural log of the natural log of the absolute value of a secant function. Now, if you remember, this negative sign could go right here and put you can put this negative instead of the negative sign, you can put that -1 here. And so that means you have 1 over cosine of theta, which is, of course, secant of theta. Okay, you don't have to write it using a secant function, but if you do see the secant function, you will know why. Okay, so this one is also a little tricky. The last part of number 7, right? And what is that? Well, just go ahead and let u be the denominator, or the parenthesis inside the expression inside the parentheses in the denominator. So u is this. U is 3x squared minus 5. Then du is 6x dx. Of course, I don't have a 6x dx. No problem. I multiply the inside by 6, divide the outside by 6. So this is 1/6. 6x dx is called du. Now what's the denominator here? All right, it's 3x squared minus 5 to the cubed, to the third power. All right, so this is 1/6 integral of u to the -3 du. What is 1 bigger than -3? Be careful, it's not -4, it's -2, right? So this is what you'll get, like that, right? So let's go ahead and try to simplify this. It's -1 over 12, and then u square plus c. You can also write this way, -1 over 12. Now u squared is 3x squared minus 5 squared. And actually, you should not be using u in your final answer, right? Because u was something you just made up, and the person who asked you the integral using x does not know what x is. So if the question is described in x, the antiderivative or the indefinite integral should always have x in it, no u. And by the way, in each expression, like, in intermediate step here, once you decide to change ships, get onto the boat of the world of u, then you should not use the mixture of x and u, because the world of x has its own language and the world of u has its own language, and never shall they meet. Okay, we'll go into the next part when we start on number 8.